Hi everybody. Today we are talking about relations and functions. So we want to be able to analyze relations and functions and use the equations of both of them. So we have some definitions at the beginning here. So a function is a relation in which each element in the domain is paired with exactly one element in the range. This is an example of a one-to-one function. So you can see that everything in the domain is going to its own individual thing in the domain, in the range, sorry. An onto function is saying that everything in the domain they're taking up all of the elements in the range here. And when it's both, they're all going to one and they're all being used up there. So we have a discrete relation, so that's one that would be graphed with individual points. So lots of times you see something like this, kind of like a scatter plot would be a discrete function. A continuous function is one that has a line that is connected that best describes that function. The vertical lines test, you may have heard about that in Algebra 1. That's a way to test to see if a function is in fact, if a relation is in fact a function or not. So if a vertical line touches the graph more than once anywhere, then it's not a function. We have the independent variable, which is lots of times x. That's the domain values or the input. The dependent variable is often represented by y, which is your range values or your output. And function notation is just another way to name functions. It replaces y when we're talking about functions usually. So a common mistake is that kids think that this is f times x because you see the parentheses there. It's not. This is just saying I'm naming the function f and x is the variable that we're going to use. So f is like the name of it and this is the variable being used. Okay, so for the first example, it says state the domain and range of the relation and determine if it's a function or not. So the domain are all of your possible x values. So if I list those out, I have -4, -3, 0, 1, and 3. And then my range will be my y values here. So I have 2, 1. We should actually put them in order. Hopefully you've learned to do these notes in pencil because I do erase stuff quite a bit. So I have a 1. Oh, nope. Again. -2 would be the smallest one here. So I have a -2. I have a 1. I have a 2, which I have them in there twice. I'm only going to list it one time because it's just saying what are elements of that domain and range, and then the 3. So is it one-to-one, onto, or both? So the best way to tell this, honestly, is to make one of these little mapping diagrams like up here. And they're really easy to make. So I'm going to put the domain in one and the range in another, and we're going to draw those lines. So I have -4, -3, 0, 1, and 3. Should have made that a little bit bigger. I have -2, 1, 2, and 3. And then for each point, I'm just going to draw the line to where it went. So -4 went to 2. -3 went to 1, 0 went to -2, 1 went to 2, and 3 went to 3. Okay, so since we have 2 of them going to this 2 over here, if I look back up at the top, you can see that's kind of like this one where 2 of them are going to the C. So this is going to be an onto function. So it is a function, and it's onto function on here. Okay, part B. So if we recognize this would just be a line. So this has a y-intercept of -1 and a slope of 3. So just a very rough sketch. The line's going to look kind of like this. And as you can see, this would pass the vertical line test. Anywhere I draw a vertical line, it would only touch the graph once. So this would be considered both. It is one-to-one, and it is onto on here. All right, example 2 is evaluating. So we have f of negative 2 and f of 2t. That's how you would read that. This is f of negative 2. That's how you would say that. So what this means is we're going to substitute that in and evaluate it. So this is saying, hey, take the function f, and I want you to plug a negative 2 in for the x. So f of negative 2 is going to look like this, and then I'm going to simplify. So this is just another way of saying like y equals or whatever. So I can just leave that as f of negative 2. There's nothing that gets simplified there. And then this side I'm going to simplify. So I have negative 2 cubed, which would be negative 8, and then minus 2 more would be negative 10. So this is the final answer to that. This is saying f of negative 2 equals negative 10, which means if I plug a negative 2 into the function f, I get a negative 10 out. If I do f of 2t, I'm going to plug a 2t in there. So as you can see, we can also replace a variable with another variable. So if I simplify this, 2t cubed, this cubed has to go to both of these, so this would be 8t cubed minus 3. And I can't do anything else to simplify that one. Alright, so my last example is give the domain and range for each of these graphs. So my domain are your x values. So here I'm looking at what are the x values where this graph starts and where does it stop. So if I kind of draw a line here, kind of sandwich this circle in between these spots, and I look at where does that cross the x-axis. So it's crossing at negative 5 and it's crossing at 1. So that means the domain of this relation would be from negative 5 to 1. And we're going to write that in interval notation, and we'll practice this more in class. So this means I'm going from negative 5 and I'm going to positive 1. The range then is the y values. So I'm going to sandwich it in like this. And you always want to go lowest to highest, so the lowest is down here at negative 1, and it goes all the way up to positive 5. So negative 1 to 5 is what my range is going to look like. Part B, if I'm looking at the domain here, so the first spot that the graph is right here, and then these arrows mean that it's continuing on forever. So this graph is starting at 0, so I'm going to say the domain starts at 0, and the arrows mean it's going that way forever. So in math, the way we do that is we use the infinity symbol, which is a sideways 8, and the infinity symbol always gets the rounded bracket on there. It's kind of like you can't ever cap off infinity or include infinity, so it always has to have the rounded bracket. So the range then, if I look from the bottom and the top here, I also am hitting arrows on those spots. So when you hit arrows, that means it's going both directions forever. So it's going down forever and it's going up forever. So that would be all real numbers, or in interval notation you would say negative infinity to positive infinity. And the last one, part C here. So my domain, this has arrows, they're just small. As I look here, this is hitting an arrow, and over here I'm hitting an arrow. So when I hit arrows on both sides, that means it's going both directions forever. So the domain, again, would be negative infinity to positive infinity. And the range is going bottom to top. So here is the first spot that it hits, and then it goes up forever because those arrows are pointing upward. So this is at negative 2 is where it starts, and it goes up to infinity. Alright, so for the last two, it's asking you which of A, B, and C in example 3 is a function. So which of these three is a function? Only one of them is, and two of them are not. And then it also wants you to evaluate f of 3 using example 2. So using this function up here in example 2, do f of 3. Alright, so lastly, need to leave you with a joke. How do you fix a damaged jack-o'-lantern? You use a pumpkin patch. Makes sense, right? Alright, hope you have a wonderful day, and I'll make sure that you are kind to someone today.